Join is the cross product followed by select. So it's so it's less messier. I mean, you have to write less to do the same. So I did this query in the last class, and so in the textbook for natural join, you can either use the just the bow tie symbol or the star symbol in the textbook. And so if you write join just by itself, without any select operator, actually the equality or whatever condition, then what it does is it picks up the attributes that have the same name. So in this case, in department, it was the D number, and department location D number. They are exactly the same. So it does that as the equality condition out here. So you don't have to write it down. So I'm going to do a few more queries with join today. So this next one is,
I had a quick question. What would happen if you had two columns with the same?
oh, just can you please repeat it? I had kept the volume down to 0.
Oh, I'm sorry. Yeah, what would happen if you had two of the attributes that were the same name in the two tables?
Yeah, so if you had two attributes with the same name, then it would, I mean, just say that again, two attributes with the same name in the same table?
In two different tables, so that, like, you know how you said it would take the columns with the same name and do that as the condition that it would use for a join. But if you had two attributes that were the same, like say you had first name and ID or something in two different tables, and you did a join with them, would you just have to specify?
Okay, so I'm not sure I completely understood. So maybe what I can do is let me just do one query, and I'll ask you whether that was a question.
Sure. Sure.
Okay, so let me just do then. Instead of doing this query, I'll do another query. Okay, let's see. Okay, let me I have to think about what I think you asked. I'm not completely certain. So what I'm going to do is let me just give you one query, and while you're doing that query, I'll try to come up with a query that kind of is doing what you're asking, or at least what I think you're asking. Okay.
Yep,
Because I have
sounds
to
good.
think about it. So let me just just do the output of this, and I'll.
Sure.
So this one does not answering your question, but I'll think of something while you're doing this. List employee name and dependent name. So I would like you all to try this out.
I have a question about one of the homework questions.
The homework, I have office hours actually immediately following this, but go ahead in case this is something that everyone needs to, has a question. Yeah, just go ahead with your question.
There's like number 4 says list the offerings that are being held in both Berlin and Dublin. Yes. And I didn't find any that were in both Berlin and Dublin.
Yeah, so, just in order to check that your query is working correctly, just add attribute, add a tuple that is there in both Berlin and Dublin, and see if your query will work correctly. Just add it to the RA file.
Okay.
And then recompile the SQL, or you can add it directly. I mean, you can do either one. So because in the next assignment too, there will be queries where there's no data in the sample file. So you have to either add or you'll have to delete. There are some queries where you might have to delete one or two tuples to get an output. And in others, you would have to add. So, so you should do that on your own because a Shihong is going to use a different sample database to test your queries.
Thank you.
Okay, so let me just write down this one. So if you did this with cross product, you would do it as but like I mentioned, it's a lot easier to do it with so so doing it like this is, it's shorter than doing it using the cross product. And if you just wanted to do the natural join, you could do it as okay, let me use the star this time. So you could do it in any one of these manners. So do anyone have any questions on this one? Okay, so I'm going to try to answer that what I think was a question that the student was asking earlier. And I don't want to use names because this is getting recorded. So I don't want any names coming up. So it's kind of weird, but I can't use names. So let's do this. So the next one is, so what is the output of the following query? Okay. Okay, so I would like you to look at the table, the company table, and tell me what the output of this query is going to be. I'm going to try to write it down in one. Okay, so I want you to try this out right now. Okay, so anyone do what is the output of this from the tables? So what are the tuples that are going to be output? So does anyone want to just give me their answer? So
it'll be all employees and their dependents who are the same sex as the employee, right?
Yes, this is right. It's dependents who have the same sex. So what the output for this is going to be from the dependent table. So you're going to have, so one, we have Michael, who's male, and it's 1, 2, 3, 4. And you have 1, 2, 3, 4 is John, that's also male. So, so we're going to have 4 male. And we also have 3, 3, 3, 4, Theodore, who's male. So what the output is dependence same sex has the parent, or the parent who's the employee who's working. So out here, so this is the natural join that I've done out here. So what it's connecting is it's connecting. So really what it is doing, it's doing employee dot social security number is equal to dependent dot social security number and employee dot sex is equal to. So it's connecting these two. So when you do a natural join, if where you're not specifying the equality condition, it'll pick up all attributes that have the same name. So in this case, it is it's sex out here. Oh. So we have sex out here and sex out here. And because I changed ESSN out here, so to SSN, so it's ESSN and SSN. Because if you look out here, I had changed that to SSN. So we have two things that match, SSN and sex and SSN and sex. So so if you don't, when you use the natural join, it'll map both. So was that the question you were asking?
Yep, absolutely. Thank you.
Okay, good. Because if you look in the tables, the only thing that link, yeah, so that's why I had to do a rename, because out here it's an ESSN. In the original table, it's an ESSN, so I had to change it to SSN. So that's the thing. So that's the thing with the natural join. All the attributes that have exactly the same name are going to be done. So does anyone have any questions? Did you understand this? Okay, so let me do another one. So this time I want to go back to a query we did in an earlier lecture. So, so I just want to bring up that query. It was lecture 5. Okay, so this was on one of our, it was a lecture we did last Wednesday, where I asked that list the projects that are common to employee 1, 2, 3, 4 and 3, 3, 3, 4. So I just want to show this query again, because we did this with the correct answer was this one, the intersection. So you can do the same query using the join or a cross product. So I just want to show that also. So I also want to show, when I'm doing this query, I also want to show two different ways of doing it, where this one way, the sizes are much smaller. So I just want to show, like, queries, while the output is all the same, internally, there are some queries that are more efficient than other queries. So I want to use this one as an example. So I just want to copy. So this is the one I just want to go back to. So this is the query. Okay, so I'm going to do a rename. So let W1 be, so this is the answer. You can see on the left, the one that I checked off is the right answer. So we have, let W1 be and that W2 Okay, so we have these two queries. So if you do a select first, so the number of rows that match up where employee social security number is 1, 2, 3, 4 is, let me just see, I've forgotten. Oh, actually it's there out here. So where it's 1, 2, 3, 4, they're just 2 rows. It shows up out here. We have 2 rows. Oh. Okay, we have 2 rows where it's 1, 2, 3, 4. And for 3, 3, 3, 4, there are 1, 2, 3, 4 rows that match this up. So if you, so when we write down this query has, so in this case, what you are doing is, since W1 has 2 rows and W2 has 4 rows, the total will be 2. There are 8 rows in the cross product, because a join is really a cross product followed by the, the select part of it. So, and then from there you select. So you have a total of 8 rows out here. On the other hand, if you wrote down this query in the following manner, so let's say that instead of doing it like this, I wrote it down as, again, now in this case, let W1 be just works on. And W2 is also works on. It's just, so that's 16 rows and 16 rows. So now if I'm going to write down the query as PNO. W1. And then join that with W2. So the output in both cases, your answer is going to be correct, but it's the number. So in this case, you have, so this particular query has 16 multiplied by 16, that is equal to 256 rows. So all of these, so so while the output for this one and this query are exactly the same, and it's a correct output, which is 2. 2 is the only project number that's common to both um, um, both employees 1, 2, 3, 4 and 3, 3, 3, 4. The difference is that internally, this query is more efficient, because in this query, you're doing the select first, and then you're doing the cross product of really W1 and W2, which is already smaller. So you only have 8 rows. While here, you're picking up the entire W1 and W2, and then at the end, you are doing the, after you do the cross product, you are actually doing this. So in terms of memory space, and this first one is more effective. It's a better, more efficient query. So do you understand? The difference. In terms of output and everything, it's the same. It's just internally. So is this clear? What I just explained. If anyone doesn't understand, I can go over it again. So I do want to explain that for you, that's the good thing about this SQL and all that, and relational algebra, is that it doesn't matter whether you write it down in this manner or you write it down in this manner. And the reason is because all SQL has query optimizers on the back end. So whatever you write, you as an application programmer write up front, these query optimizers on the back end will execute this program in the most efficient manner. So as an end user, it doesn't matter whether you write it like this or you write it like this. But I want you are all computer science graduates, so some of you are going to work on the back end. You're going to work as query optimizers and things like that. So, so it's important that as computer science graduates, you understand that there is a difference in these two queries, even though the output is the same. But the database will handle it for you. So application end users don't need to worry about it. It'll get run efficiently. Okay, so I would like to do another query that we did on the same lecture, which is this one, this next query. So I don't know why this is not, okay. So this is the one, list social security number of all employees who either work in department 5 or supervise an employee who works in department 5. So we did this particular query using the union. So this was the solution for this query. So we found the social security number of all employees who work in department 5, that's this one. And then we found the ones who supervise an employee in department 5. And then we just did a union of the two. Okay, so I'm going to change this query just slightly. So don't know why it's not working, the switch. Not able to switch to this particular screen. Just one second. I don't know why it's not working. Okay, for some reason, I'm not able to switch to the, not able to move here. When the software doesn't work properly, it's a real pain. So I'm going to close the one on the left. I would have liked to have it there, but it's not allowing me to write on the right. So it's the same query that I just showed you. I'm just changing it a little bit. I'm adding. So the query that we just did was social security number. So I'm going to say social security number, and I'm going to add, this is the only thing I'm adding to it, and names. of employees. Okay, so this is the only thing I added to the query we did last week is that I'm adding, I want the names also of employees who either work in Department 5 or supervise an employee who works in Department 5. Actually, I would like you to just try it. I'll bring up the old one again now that I'm doing this, but I would like you to see if you can do this one. So. So this is the, on the left is what we did last week, and I've just added and names. And I just want you to see if it's, you know, it's just a simple add-on to the one you did to the left. So what I'm saying is, so this is the one we did on the left. Oh, if I switch now, I don't know whether I can. So I'm going to write down what we did last week, because if I switch to the other screen, I'm not able to come back here. So if I did pi, so here it was SSN name. Union. And then the rest of it, you know, if I just wrote the, what were pi. So would this work if I just added? So I just want to see, if I wrote, so I'm just writing down the same query that I wrote last time, which worked. That was the solution to just social security number. So all I did is I've added first name. So in the last class, I didn't have F name, so I added it, and now I'm going to do a union. So will this work? And actually it doesn't work. So can you tell me why this will not work?
Because you're looking for the supervisor names as well, and that would just give the employee names.
Yes, you're right. You know, that's what you just said is correct. It just gives you the employee name. So let me just give you one line of the output. So for example, so let's see, company data. Oh. No, this is really confusing to bring it up sometimes. So I just want to bring the company database back. Okay, so I don't have the company database, but what it's going to do is, let's see. Okay, so it's going to write down, and since I don't have the company database in front of me, so the output is going to be two lines of, it's going to show, so 1, 2, 3, 4, let's say, and let's say 1, 2, 3, 4 was in department number 5. So I don't even remember what 1, 2, 3, 4 was actually. Just one second, let me just try one more time. Okay, I got it there. Okay, so let's say, so we show 1, 2, 3, 4, and it shows John. The output will have John. And it'll also, again, it'll show, so John supervisor is 3334, and it'll again show John, and so on. So for each case, what it does is that, so here it should not be 334 John, it should be 334 Franklin. But if you do a union like this is the output you're going to get. So this query cannot be answered by just adding on the first name. And if it's not clear to you, and it might not be, because you should try this particular part out later. If you don't understand why this does not work, I recommend that you try it out on your own after class. Just check it out and then see if you can understand why it's not working. So in order to do this query, you actually have to do it a bit differently. So let me just show how to do this query. So one way of doing this query is, so let A be okay. So so A is you're taking out the supervisor's social security number for all employees who work in department number 5. Then let B be employee. Okay, so then you do a cross product between employee and A, and then let C be or set B. Okay, so now this set C, it lists the first name and social security number of supervisors who supervise an employee in department number 5. So this is what, so this is the query. The C is going to give you that particular one. Okay, so A, B, and C are, you end up, you're going to get this. And then for the other part, who work in department number 5, let's say is D. So that part is the same as last time. So first name. Okay, and so then the result that you want is going to be C union D. Okay, so just changing the query very, very slightly. That is, instead of just doing social security and just adding names, it just changes. I mean, so then you can't use the old query at all. So this one is not going to work. And so the right answer is this one below. So again, I know this is, since we're doing larger queries, they are a bit complicated. So it's okay, just try this one out on your own, the one that out here, and check it out and look at the output and try to understand the output, and then you'll understand why this does not work. Okay, so does anyone have any questions? And one of the things I recommend with the assignment, for example, the first assignment was, rather simple. So on the second assignment, again, I have, I think, 6 queries. I'm not sure if I gave you 5 queries or 6 queries. I should look. But some of them are simple. But I would say that, maybe 1 or 2 queries, it would be easier if you did the query in parts, split it up into like the one like I did out here and break it up. It'll be a lot easier to do it that way. Okay, so so this was just join where I'm joining two tables. So you can join many tables together. You know, it doesn't have to be, you can join all 5 tables together if you want. So this is the n-way join. So list each project name with its department manager's name. So what are the tables that you're going to need for this query? Does anyone want to answer? Which tables would you need to answer this query?
Department, project, and employee, I think.
Employee, department, and project, right? Is that what you said?
Yeah.
Okay, yes, you're right. So now you're doing a join with 3 different tables. So so the way to do that, and you know, you can, so you want project name with its, so you do have to do a pie, but the tables that you join are going to be project, join, department, and I'll write the join conditions after that. So I just want to write down the tables. Join, employee. So these are the 3 tables that you're going to join. I would like you to write down the join condition. I just written down the join operator. I would like you to write down the, you know, just fill in this condition out here. The select condition. Okay, I hope this is what everyone got. And if you do the table, the diagram, you have pi. And of course, all I wanted was the so F name, D name, P name. So I didn't do the pi operator, but you should do a pi around the whole thing. And, you know, so you're going to put all that down. And if I just want to do the tree diagram, it's sometimes useful. So here, so that's the 3-way join. You know, connecting all the different tables, and you have to be careful. So remember that, you know, this is easy, but just be careful of one thing is that, for example, if you look at the employee tables, I'm going to switch to the other table. Now, if you look at the employee table and the department table, if you had connected the department number here with the D number out here, your answer would be wrong. because there are two things that are connecting. There is a manager social security number here. So this thing, there here, and then you have the department number with here. So just be careful. The join part is fine. Just be careful that you join the right attributes together, because otherwise you're going to get the wrong thing. So if you had joined the department, you'd be writing the names of the employees who work on that particular department, because that's what you're joining on. So it would not be the correct answer. So in SQL, another thing I just want to, and so this one is also kind of important, is that in SQL, the order of joins does not matter. But in relational algebra, it does matter, because relational algebra is doing it like math. So it takes it from the left. So it's another thing you should be aware. So I just want to write this in red because this is important. Oh, okay. Okay, so it does not matter. So the way you order it, it will not matter, but the way relational algebra, so when it's looking at this particular thing, it's first doing this join before it does this join. So it's doing it from left to right, and and knowing that is important when you write queries, because otherwise you're going to get errors sometimes. Okay, so I would like you to try out this next query. So I would like you to try this out. List the employee name along with the employee's project name. Okay, so here, and so that I just wanted to, I do it in two different ways to show you that, so if you connected works with project, so at that point you did the P number is equal to P number, and then the rest, when you're connecting it with employee, you connect the social security number. So the order itself does not matter, both this, or if you put employee first, it's all going to give you the same answer. So any questions? Did you understand? Do you think you understood the join operator? So for the assignment, you can use join instead of using the cross product because it's a lot easier to use the join rather than the cross product. So, you don't have to use the cross product at all. I'm trying to see, there are some queries where sometimes you would need a cross product, but yes. So any questions?
Are you going to ask that we use either the cross product or a join explicitly for like quizzes?
On quizzes, because you have to know everything, because one is I can't have you write down any query because you're doing it online and it takes a lot of time to go to the math mode and write it. So I'm going to be giving you all the relational algebra queries, and really what I'm going to ask you is to either give me the output or whether that's the correct, whether the query is doing something like this. So you would have to know how they work.
Oh,
But
okay.
this is an exam. I mean, I'm not going to ask you to write anything because you're doing it online. So you should, so since I might use cross product in a query that I'm giving to you, you should at least know how it works. So any other questions?